All right, we're now into lesson 3. This is kind of the advanced level that you could say of all the content we've been looking at. We're going to just try to combine it and work our way through. This one's going to be using some tables as well as graphs. So we're going to do lesson 3. I'm not sure how many problems, but let's see if we can keep it to maybe a 15-minute video, and then we'll see where we're at. Lady Tata comes out with a new song and puts it on YouTube. At time t equals 0, the song is being downloaded at the rate of 12,000 times per minute. 12,000 times right here per minute, or per week, times a week. Sorry. The rate increases for a few weeks, but then starts to decrease. The rate of downloads is shown in the graph below. What does the definite integral from r of t from 0 to 8 represent? So it's not even asking us yet, but it's saying, what would this area be? Well, the area is going to equal the, what is this? It's going to be something times weeks. Oh, it's the downloads per week times weeks. So that's going to give us just the total downloads if we find that area. There we go. So estimate this definite integral by counting and estimating rectangles. All right, so we got 1, 2, 3, 4, 5, 6, 7, 8. I'm going to count this as a full one. So that means we got 16 for these first two rows. And we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we got 16 and 14. So far I'm at 20. Now I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So that's about 30 full ones that I've done so far. So the blue, we got 30 full ones plus how many, let's say, half ones. Well, this looks like a half, this looks like a half. Those kind of round each other out. And if you kind of put these two together, those like two halves that make a whole. I didn't count this one here. So I'm going to count that one, but I'm not going to count this or this. Actually, no, I will count that one. That looks like a half. I'm not going to count this one, but we'll count this one. So I got 1, 2, 3, 4, 5. Maybe these two together make, or these are about halves. 6, 7, 8, 9, 10. So I got about 10 halves. So that's about 5 there. So I got about 35 rectangles, and each rectangle, just change pens here, so this equals 35 rectangles, and each rectangle is 1 week by 2,000. So that's going to be 35 times 2,000, because that's how much each rectangle is worth, which gives us 70,000 downloads. That's a lot. It's not as much as I was expecting. Maybe I'm off by something here. It's at 700,000. Let's double check it. 35 times 2,000. So we got 35 times, well, clear that, graph, clear, 35 times 2,000. 70,000, so that's right, check, 70,000 downloads. Let's continue on to the next part of this type of problem. Looks like we're still going further with parts C and D, same problem. On the figure at the right, divide the region which represents definite integral from 0 to 8 into 4 trapezoids. 4 trapezoids. So that means I gotta start here and here. I'm going every 2, because if I'm going up to 8 and I count by 2s, that splits me up into 4 intervals. So I got trapezoids. There's one, here's another one, here's another one, and then the final one. Alright, so check. Did that. Now estimate the value of the definite integral from 0 to 8 by estimating the areas of the 4 trapezoids. Is this an under or overestimation of definite integral? Well, I'm going to say right now it's under, because there's parts of the area that are not included. So those are things that we forgot to count, you could say, if we're shortcutting it with these intervals of trapezoids. So for this interval, we need to find the area of a trapezoid. Let's review that. Well, the area of a trapezoid, I don't know if you remember, we kind of have a height, and then these are bases. We'll call this base 1 and base 2. And to find that area, the area of a trapezoid is equal to half, or the average of the bases, and then times the height. Right, so we got base 1 plus base 2, so that's 12. And then this one is, oh, that's kind of a in between, so that's about 23. So we're going to do half times 12 plus 23 times the height, which in this case is 2. So that's the area of the first one. Let's look at the next one. The area of the second one is going to be half, and then we're going to add a couple of things. And then we're going to multiply it by 2. Why? Because the height is still 2. It's 2 for each of these. Or that width, I guess you could say. Whatever it is, it's not really important. Oops. Turn the touch on and off on the pad here. Now we're back. Alright, so for the second one, we're 2 by, these bases are 23, and then this other one is about 22. So we're doing 23 plus 22. Now the last one we got 22, and then this other one looks like it's in between again, so we're at a 13. So now we're going to do, for the third one, it's 1/2 22 plus then a 13, also times 2. And then the last one's going to be 13, and this goes almost down to 0. I'm going to call it 1,000. Well, not really 1,000, but 1. So we got 1/2 times 13 plus 1 times 2. And the area of the fourth one equals that. So there's our 4 areas. I'm going to put them in a box here so you can see what we're looking at. If you need to go back and take a look at how I got those, think of this formula and think of the numbers that I was measuring here. Now immediately I notice that these halves and 2's are going to reduce because 2 times 1/2 is just 1, so we don't really need that. So I just got to add up all these numbers. 12 plus 23, 23 plus 22, 22 plus 13, 13 plus 1. Well, there's a lot of repeating going on there. Add them up. We got 12 plus 23 plus 23 plus 22 plus 22 plus 13 plus 13 plus 1. Oh, looks like I missed some. 13 plus 13 plus 1. Alright, so that's what we got. Oh, I missed something there. Let's re-enter that. This 1 is extra up here. Those 13s were throwing me off. There we go. 138. So that's 138. This equals 138. But it's not just 138, it's 138,000. Alright, let's talk about units for a second. Do we have anything? Oh, this was the same thing. So it's 138,000 downloads. Why was I so far off before? I don't know. Maybe it was different looking at these boxes. Each box is 1 by 2,000. So each box was 2,000, and I calculated how many of them? 35 of them. I guess we're off. We're going to have to take a look at that a little more in depth. So we have those trapezoids. We added them all up together, and we get 138,000. It's kind of interesting. This is actually pretty close to double that. So maybe there's a divide by 2 somewhere that we're missing. Just to make sure, we're going to double check this in class as well. Alright, let's look at the next one while we're at it. Rather than estimating, here are the values of R of t at each integer. Estimate the definite integral from 0 to 8, but find the areas of 8 trapezoids. Is the answer D or E a better estimation? I'm going to guess D is definitely a better estimation because we're narrowing our intervals. Whenever you narrow your intervals, you're looking at more accurate times of measurement. It's not every so often, but a lot more regular. So this first one, we got a trapezoid. And it's the first base plus the second base divided by 2. So we got 12,000 plus 19,200, or 19.2, times the base for this one's going to be 1. We're taking half of that. Plus the next one, so that was just the first one. Now we're going to look at this next one from 1 to 2. So that's going to be 19,200, or 19.2, plus 22.8. Notice that I'm kind of not dealing with that 1,000 quite yet. The height again is 1, but then we got to multiply trapezoids by a half. Plus, now we're going to continue this on. So actually I'm going to pause the video, fill these in, and then you can go back and see them. But the numbers are actually going to increment very regularly. And like magic, it's done. So pause the video if you need to copy it down. Alright, so here's all the calculations that we're doing. Notice that it's like you're taking one from one end and one from the next one. But then you do these two, and then these two, and then these two. So you got a lot of repetition, a lot of duplication. I also notice that if I look at 1/2 is in every term, so I'm going to factor out that 1/2. Now I'm going to just add up all these numbers. So I'm going to go to my calculator. We got 12,000 plus, now I got 2 of these 19,200. So I'm going to do 2 times 19,200 plus, then I got 2 of the 22.8s. So 2 times 22,800. Then I keep on going, repeating that same pattern, plus 2 times 23,400 plus 2 times 21,600 plus, now we got to the next one, 2 times 18,000, 2 times 18,000 plus 2 times 13,200 plus, what's the next one? We're almost done here. Plus 2 times 7,800. I meant to do 2 times 7,800 plus, now the last one, there's only one of them. There's not 2 of them. So the first one and the last one, there's only one of those. So plus 2,400, or 2,400. Oh, that's a lot. Let's see what we get. 266,400. So this total equals 226,400. So I know that we're just estimating here, but still, these trapezoids, if the curve has like this kind of downward concavity, then our lines are always going to be underneath them, which leaves this shaded area that's left over it. So it's still going to be an underestimation, but E is a better estimation. I don't know why I circled D. Why did I circle D, guys? Who knows? Well, E is it. Alright, so we are going to finish the next problem in the next video. So, we'll see you then.